Hello everybody, today we are going to learn about Fourier series. What are Fourier series? Fourier series, a series of either sine or cosine function. You already have learned about a series in your previous classes. That series is just a sequence with plus or minus sign. So what is Fourier? Here Fourier is a mathematician that give Fourier series. So series of either sine or cosine function, that is called a Fourier series. For example, a naught cos 0x plus a1 cos 1x plus a2 cos 2x plus a3 cos 3x plus up to so on plus b naught sine 0x plus b1 sine 1x plus b2 sine 2x plus b3 sine 3x up to so on. A series of either sine or cosine function. A series which have sine and cosine or only cos or only sine, that is also considered as a Fourier series. When we add these terms, we get cos 0x. What is the value of cos 0x? That is 1, and then a1 cos 1x plus a2 cos 2x plus a3 cos 3x plus up to so on. b0 sin 0x, 0 multiply x, that is 0, so sin 0 will be 0, so this whole term will be 0 because these all terms are basically multiplying with each other. b0 multiplied by sin 0 value is 0, so b0 will be already 0. So here we get b1 sin 1x plus b2 sin 2x plus b3 sin 3x plus up to so on. Now when we add a0 and when we give a representation to this series, summation n1 to infinity an cos nx plus summation n1 to infinity bn sin nx. So here when we took common summation from last two terms, we get an cos nx plus bn sin nx. And here in the formula given by Fourier, by definition, they give us here a naught by 2. Instead of a, they give in the definition a naught by 2. Now you might be confused that if here is a naught, why we consider a naught by 2 in the definition. A naught is just a constant. We can took any constant here. We can took 1 by 2, 2 by 3. We can take a, b, c, any constant. So just to make calculation easier in the next sums, so we just put here a naught by 2, any constant. So this is basically a definition of Fourier series. This is basically a formula of Fourier series. A naught by 2, summation n1 to infinity, an cos nx plus bn sin nx. Now we are going to learn about Euler's formulas. Euler's formulas. What are Euler formulas? According to the definition, Fourier series a naught by 2 plus summation n1 to infinity an cos nx plus bn sin nx. Here a naught, an, bn, they all are called coefficients, Fourier coefficients. They are all called Fourier coefficients. So what are the values of a naught, an, bn? That is called Euler's formula. How we find a naught, an, bn? By Euler's formula. So first Euler formula, a naught. A naught is equal to 1 upon pi 0 to 2 pi. It depends upon the limit. If the limit is 0 to 2 pi minus pi to pi, that totally depends upon the limit given to you in the formulas. So a naught is equal to 1 upon pi 0 to 2 pi fx dx, and an is equal to 1 upon pi 0 to 2 pi fx cos nx dx, and bn is equal to 1 upon pi 0 to 2 pi fx sin nx dx. There is no formula of b naught because b naught is not given in the Fourier formula. So a naught, an, bn. 0 to 2 pi is basically a limit that will be given to you in the sum. If there is a limit of minus pi to pi, then you will change the limit 0 to 2 pi to minus pi to pi. So these are called Euler formulas. Now you should have some knowledge about periodic functions and even odd functions. What are periodic functions? Periodic functions are those functions which repeat their value which repeat their value after a period of time. All trigonometric functions are periodic functions with different periods. For example, sin x, cos x, secant x, cosecant x. They repeat their value after 2 pi. For example, sin 90-degree value is 1. Then if we add 360-degree to it, that will be sin 450-degree. The value of sin 450-degree is also 1. So the period of sin x is 2 pi. Same as it is cos x, secant x, cosecant x. Tan x and cot x period is pi. For example, tan 90-degree, that is equal to infinity, or you can say undefined. Then tan 90-degree plus 90-degree, tan 180-degree is also undefined or infinity. Now there are different type of periodic functions with different type of periods. For example, in the question, sine and theta and cos and theta are periodic functions with period 2 pi upon n. Same as it is, there are different type of the functions with different type of the periods. If there are secant and theta or cosecant and theta, we just divide their n with 2 pi or pi upon n. Now what are even and odd functions? Now what are even and odd functions? Even functions, if we change function x, positive x to minus x, then the answer will be same. For example, we can take cos. Cos x is a function, and when we put minus x, that will absorb minus cos x. So this is cos x and secant x are basically even functions. So what are odd functions? Odd functions are those functions which does not absorb minus. They kept outside the function in this type of functions. For example, sine minus x, when we put sine x, if function is equal to sine x, if we put minus into it, and minus will be outside of the function, so fx minus fx is basically minus fx. So that are called even and odd functions. One thing you have to remember, that if the limits are 0 to 2 pi, in between 0 to 2 pi, then you have to find a naught, an and bn. If the limits in between minus pi to pi, then you have to check even or odd function to make calculation easier. If the function is even, then if the function is even, then bn will be 0. If the function is odd, then a naught and an will be 0. Only you have to find bn. So the function is even, then you have to find a naught, an. Bn will be automatically 0, you don't have to find bn. If the function is odd, you have to find only bn. So in even, bn is 0, in odd, a naught is 0. So this is extra benefit in this limit, that if you don't want to do descriptive calculation, you can just check even or odd function, but it doesn't apply in 0 to 2 pi. Now we will solve our first question, that is expand in Fourier series the function fx is equal to x in the interval 0 to 2 pi. You already know that if the interval is 0 to 2 pi, then you don't have to check even or odd function. You have to find a naught, an and bn. So how we solve this sum? First step is let assume function is equal to series. What is the purpose of Fourier series? Just to find a series for the particular function, and particular function should be a periodic function. So let fx 1 by 2 a naught plus mission n1 to infinity a n cos n x plus mission n1 to infinity b n sin n x. This is a formula of Fourier series. First we put fx is equal to the series. In every sum, first step is put fx is equal to the series function. Then when we want to find series, you have some knowledge about a naught, an and bn, and you have to find a and bn, a naught by Euler's formula. We already discussed Euler's formula. A naught is equal to 1 upon pi 0 to 2 pi fx dx, 1 upon pi 0 to 2 pi x dx. When we integrate this, we get x square upon 2, 0 to 2 pi. And then when we solve this and put the values, we get a naught is equal to 2 pi. And then an 1 upon pi 0 to 2 pi fx cos n x dx, 1 upon pi 0 to 2 pi x cos n x dx. And then we integrate this by the formula, first term as it is, second term integration minus integration of derivative of first, and then integration of second 0 to 2 pi. And then we put separate values to the first whole term and the second whole term. And when we put these values, we know that the integration of cos nx will be sin nx upon n. And you know that sin 2 pi 0, sin 2 n pi 0. And when we put all these values here, we get sin 2 pi n, that value is also 0, sin 2 pi n, that value is also 0, sin 0 is 0. And when we put whole values, then the answer is 0. So an value is 0. Now we want to find bn. Now we want to solve bn, that is 1 upon pi 0 to 2 pi fx sin nx dx. And here we put function value x here, 0 to 2 pi x sin nx dx, 1 upon pi. First function as it is, integration of second function minus integration of derivative of first, and then integration of second function 0 to 2 pi. 1 upon pi 1 upon pi, then we do integration of sin nx, that is equal to minus cos nx upon n, 0 to 2 pi, minus derivative of x, that is equal to 1, integration of sin nx, that is equal to minus cos nx upon n, in 0 to 2 pi, 1 upon pi, then we put value of 2 pi and 0 here. And you know that cos 2n pi is equal to minus 1 2n, and 2n is even, so answer will be positive 1. Sin 2n pi is equal to 0. We put the respective values here in the integration. And when we solve these all values, we get 2 upon n. The value of bn is equal to 2 upon n. Now, from the first equation, in the function fx a naught upon 2 summation n1 to infinity a n cos nx plus summation n1 to infinity b n sin nx, we put the whole values. A naught is equal to, what is the value of a naught? That is 2 pi. A n, that will be 0. So if a n 0, then multiply cos nx, that this whole term will be 0. Then we put bn value, that is minus 2 upon n. Here there is a minus, so that will be minus 2 upon n, minus 2 upon n sin nx. Answer will be pi minus summation n1 to infinity 2 upon n sin nx. So pi, and then we put value of n in this function, 2 upon 1 sine x plus sine 2x upon 2 sine 3x upon 3. The answer of the series is this. With this method, we will solve our Fourier series. Thank you.